Hello there. Now we are trying to see what is the virtual displacement. In the previous video we do have seen that there is a physical work is going to be happen, or the mechanical work is going to be happen by physically the particle is changing from one position to the other positions by applying the force. And then we can say this is going to be a mechanical force, or maybe the physical, the force is acting, then we can say that is the physical work or the mechanical work. Now we are going to be see, even though the body is going to be existed in the equilibrium condition, so then how we can make the work and what is the virtual displacement. Now we are going to be discussing what is the virtual displacement. As you know, the displacement is nothing but changing the position of a part or a particle from one position to the other position. We can say that is the displacement. So then what is the virtual displacement over here? So that's we are going to be discussing. So now see, and we are going to be giving a certain kind of the conditions to the system, and we are made to subject it to the different types of the forces, and then we are considering and how it is going to be reacted, and that's we are going to be discussing here. So when a system of forces acting on your body, so can you see here I have taken a system of the forces. So system of the forces means a group of the forces is going to be acting on a body are in equilibrium. These forces are in the equilibrium condition, or at the same time the body also in the equilibrium condition. As we know, the equilibrium conditions already we have discussed about the position, that summation of the forces in acting in the horizontal direction is equal to 0, the summation of the forces acting in the vertical direction is equal to 0, and the moments are acting with respect to any point is equal to 0. So then the displacement of the body would be 0. When the system of the forces are in equilibrium, when they are acting on your body, the displacement of that body would become a 0, because that body cannot move either in the x direction, not in the y direction, or not in the z directions, because that system already is in the equilibrium condition. So then what will happen? So that condition is pushing the body with no work is going to be possible. So that work of that generated by that, the work by that body is going to be 0, or the work generated by these forces will becomes to 0. So but what will happen? So but we need to use this principle of virtual work method to find out the forces in the respective members, or internal forces of the members we need to be calculated. Then how we can take the advantage of this the principle of virtual work for this concept. But an imaginary infinitesimal displacement means here we are taking imaginary infinitesimal displacement. Actually there is no physical displacement is not available, then we are considering there is an imaginary displacement we are going to be considering to that body, and can be assumed to be given to the body in the equilibrium condition. Even though the body is existed in the equilibrium condition, so then what will happen? The body is going to be imaginary infinitesimal we are going to give it. So these statements I am going to be trying to put in the pictorial view. The same time I am going to be taking here is going to be the particle P. So what condition we apply here? That means the system of the forces we apply to that system. That means I am going to be taking here is the number of the forces. Suppose. So this is going to be F1, F2, F3. Suppose this is the F1, F2, F3 and F4 forces. That means the system of the forces are acting on that body. Then what will happen? In this case, if you consider the body is going to be in the equilibrium condition, so then there is no displacement, physical displacement, but we are going to be assuming there is going to be an imaginary displacement. So that means the particle will try to move in the resultant component of the forces. So this way, that this is going to be called your imaginary displacement. Then such a displacement we are going to be called the virtual displacement of the body, and it is creating an opportunity to become the virtual work. So now we are talking about the virtual work. So already we have discussed about the virtual displacement, that is imaginary displacement even though the body is in the equilibrium condition. So the resulting work done by the force acting on the body during the virtual displacement is called the virtual work. The resulting work done, it means the finally what is the resulting from this one? When the body is going to be subjected to the force as well as the virtual displacement, that leads to the work done. The work work done by the force acting on a body during the virtual displacement. So that means the product of the force and the virtual displacement we are going to be calling here the virtual work. Right? Virtual work is going to be nothing but again it is the imaginary work. Actually, there is no work is not going to be happen, but by applying this virtual work, we are going to be finding the forces in the particular members. So here the notations what we are going to be providing. The linear displacement I am going to say del x and del y in the direction of the x and y respectively. And similarly, angular displacement we are going to be taking del theta. By using these notations, we are going to be trying to find out the virtual displacement as well as the virtual work of that system. So, after discussing the virtual displacement and virtual work, now we are going to be talking about what is the principle of virtual work. So, what is the principle of the virtual work? As we know, already we told a system of the forces are acting on a particle and then the body is in the equilibrium condition. But we are imagining there is a displacement is going to be existed, that is imaginary displacement. So then the system of the forces means the number of forces are going to be acting and each and everything it will going to be generate its own kind of the displacement by the imaginary. So on that basis we are going to be defining what is the principle of virtual work. So here if a rigid body, now we have taken a particle is going to be here is the rigid body is in equilibrium. So when the body is in the equilibrium condition, even though there is a system of the forces are acting, so here the total work of the external forces acting on the rigid body is 0. Suppose in this case what will happen, the total work, so that means external forces, how many external forces are going to be acting on this system, that force into displacement and work 1, work 2, work 3, that means the external forces acting on the rigid body, then the total work is equal to 0. So then for any virtual displacement of the body, they consistent with the geometrical conditions of the body. In this case, while you are defining the total work is going to be 0, there must be a virtual displacement of the body consistent with the geometrical conditions of the body also we are going to be taking into the picture to define how the total work is going to be 0. So these kind of the definitions, that means the total work is equal to WBP is equal to 0. In this case, how we are going to be writing? That's going to be F1 into ds1 plus F2 into ds2 plus F3 into ds3. That means the system of the forces are acting on a particle and they have their own individual displacement because of the force F1, F2 and F3. That is going to be ds1, ds2, ds3 respectively. So then that is equal to 0 we are going to be considering. On that basis we are going to be finding any unknown forces acting on that member or internal force of the members we are going to be calculating. So we have seen the definition or the statement of the principle of virtual work. Even though that means we have seen that the system of the forces are acting on a particle or on the rigid body. It means all the forces cannot generate that kind of the work. That means here the forces which do no work when it is acting on a body. So what are the forces are going to be which is not generating the work? So here the weight of the body, so one is going to be the weight of the body we are going to be saying. As we know, the weight of the body is going to be acting from the vertically downward direction or vertically upward direction. So then what will happen? The displacement we are going to be considering, the force into the displacement, that means the weight into the displacement means it will generate the work. But when its center of gravity moves in a horizontal direction, so that means when the particle is going to be moving in the horizontal direction, it means that when the particle self weight is going to be W, actually it is always acting towards the gravitational point. So when it is going to be moving in the horizontal direction, so then what will happen? So the displacement, because due to the self weight there is no displacement is generating in the horizontal direction, then automatically that force is going to be 0. That means the work done due to the self weight of the system is going to be 0. The reactions at a frictionless hinge, as we know, when the hinge is going to be there, so automatically the body is going to be start to rotate about that point. So the reactions at the frictionless hinge means when a body rotates about the hinge, when the body is going to be rotating about the hinge, so then because of if you draw the free body diagram, we used to find out the reaction forces at that point. So then, because of this reaction forces, because it is not going to be generating any kind of the work. That reason here is that because of the reaction forces, it is not getting any kind of the displacement. But we need to consider that's going to be zero work done because of the reaction. And the third point is that the reaction at a frictionless surface. So when there is a reaction at the frictionless surface, so when the body moves along the surface, so then what will happen? The frictionless surface is going to be the reactions, whatever it is going to be generating, that is not going to be coming into the picture for the generating of the work. That means due to this reaction forces also generate no work. So there are some other forces also. Because of that, there is no work generating. So that one more is going to be the friction force acting on a wheel. So as we know that when it is going to be rolling on the horizontal plane, the reaction forces, that means the friction force is acting always opposite to the motion of the body. It's trying to opposing the motion, suppose. So then when it rolls without slipping, in this condition also, because of this frictional force, there is no work is going to be generating on the body. And the fifth point is that the internal forces of the nature of the action as well as the reaction, right? So in this case, what will happen? The internal forces of the members. Already we do have seen in the trusses are the structures where we are going to be finding the internal forces of that member. So then what will happen here? Because of this also, there is no work is going to be generating on that part. So examples are the tension in the string, and the next one is the axial forces in the bars. So in this case, what will happen? Because of these tensions or forces in the bars, axial forces, because there is no work is going to be generating on that body. So I hope you are able to understand what is the virtual displacement and what is the virtual work and the principle of virtual work, and what are the different conditions even though the forces are acting on that body which they are not going to be generating any kind of the work. So thank you.